Okay, so today we are going to discuss the Jan 2022 P4 paper. So we'll start with the first question. The curve C has equation xy equal x square y plus 6, and they have told x is not equal to 0 and y is not equal to 0. Find an equation for the tangent of the curve at the point P 2, 3, giving your answer in the form ax plus by plus c equals 0, where a, b, c are integers. Okay, so basically what do we need to do to find the equation of for the tangent to a curve? We need to get the gradient of the tangent. Simply gradient of the tangent. How do I get the gradient of the tangent? We need to differentiate and find what? We have differentiate and find the value of dy by dx at the point 2, 3. So the thing here is the challenge here is to differentiate, because you can see here we need to use implicit differentiation because you have xy products. I mean, you don't have y, y is not the subject here. So let's differentiate. What do we get here? So I will differentiate with respect to x. Okay. So I'll differentiate with respect to x. And what do I get here? So xy square, it's product rule. Using the product rule, let's do it. So one person stays, x stays while y square differentiates. What do we get for the differentiation of y square? First, you give priority for your power. 2 y to the power 1. After you're done with the power, go and differentiate y. Yeah, we differentiate y with respect to x. Therefore, we get dy by dx. Do you remember this? So it's there in your P4 book, right? So first priority for the power. After you're done with the power, go inside. Y differentiation is dy by dx. Then plus, now it's product rule. Now the y square weights. So now the previous is x square weights. Now the y square weights. While we differentiate x with respect to x. So x with respect to x is 1. Equals the other side x square y. Again, we need to use product rule. So what do we happen? What happens here? X square weights while y differentiates. What do you get for the differentiation of y? Directly dy by dx. Differentiation of y, because it's with respect to x, it's dy by dx. Then y weights while x square differentiates to give you 2x to the power 1. Okay, and then plus, that part is done. We use product rule here again. The differentiation of plus 6 is 0. Okay, so now I need to find dy by dx, meaning I need to make my dy by dx subject. So let's rearrange 2xy dy by dx. Shall I bring the dy by dx terms to answer? I'll bring this here. And shall I take the y square term to the other side? So I get here minus x square dy by dx. Minus x square dy by dx equals what is remaining on the other side? Here I have y into 2x is 2xy plus y square goes as minus y square. Take dy by dx out. And what do we get here? 2xy minus x square equal 2xy minus y square. Do you agree with me? Then I end up getting here dy by dx is equal to 2xy minus y square over 2xy minus x square. Okay, so I get to this point, and then I need to find the dy by dx at the point 2, 3. So let's substitute the point 2, 3 at 2, 3. So what happens to the gradient? Dy by dx gives us 2 into x is 2, right? 2xy, y value is 3, minus y square is 3 square. Divide by 2 into, again x is 2 into y is 3, minus x square is 2 square. Do you understand? Can you all type this in the calendar and give me the simplified answer? Is it 3 over 8? Yes, so we get dy by dx is 3 over 8. So this is what? This is the gradient of a tangent. So this is the gradient of a tangent. So now I need to find the equation of the tangent. So how do I find the equation of tangent? Y minus y1 equals gradient. X minus x1 is the equation of a straight line. So here the y1, x1 are the two coordinates, right? They are the xy coordinates of point P. Y minus y1 is 3, gradient equals to 3 over 8. X minus x1 is 2. So I'll take the 8 to the other side, multiplying it with y minus 3. Because they have told us to get the answer in the form of ax plus by plus c equals 0, where a, b, c are integers. So I end up getting here 8y minus 3 times 8 is 24 equal 3 times x minus 2. Shall I open the bracket with 3? 3 into x is 3x minus 3 into 2 is 6. So take everything to one side. 0 equal 3x minus 8y plus 24 minus 6. You could of course reduce your number of steps by doing this in one go. 24 minus 6 gives me plus 18. So this is the equation of my tangent. Okay. Okay, question number 2, part A. Find in ascending powers of x the first three non-zero terms of the binomial series expansion of the cube root of 1 plus 4x cube. Okay, giving each coefficient as a simplified fraction. Okay, so what is the binomial expansion? Now, the first thing is you need to remember this equation, the expansion of 1 plus x to the power n. So, what is the expansion? It's 1 plus nx plus n into n minus 1 x square over 2 factorial. How far do they want us to? They want us to get the first three terms, three non-zero terms. So, I have here 1, 2, 3 non-zero terms. So, let's input our value here. So, first thing is this 1 plus 4x to the power 3 whole thing to the power cube root means the power of 1 over 3. The power of 1 over 3, right? Okay, now what we need to do here is you need to replace your n value with 1 over 3 and your x value will be replaced by 4x cube. That's it. So replace 1 plus n is 1 over 3 into x is 4x cube. So I just replace the nx value here. Then plus n is again 1 over 3 into n minus 1 is 1 over 3 minus 1. X square is, who is x? X is 4x cube. So x square means 4x cube whole thing square. Be careful here. 4x cube whole thing square. Whole thing square and then divide by 2 factorial. Shall I divide by 2 factorial as 1 over 2 factorial? So this is the second term here. This is n minus 1 x square over 2 factorial is what I have written over here. So let's simplify term by term. What do we get here? 1 plus 1 over 3 into 4x cube is 4 over 3x cube. The other guy, of course, it's better that we type it in the calc. So I get here 1 over 3 into 1 over 3 minus 1 into, now here be careful, this is what? This is 4, the power 2 comes not only to the x cube but also it comes to the 4. So which gives us what? 4 square here. 4 square in the sense this is 16. 16x to the power 6 because the power 2 comes and multiplies with 3 in x. So then you get here 4 to the power 2, x to the power 6. So basically it's a 16 or it's a 4 to the power 2 into 1 over 2 factorial. Okay, into 1 over 2. 2 factorial is actually 2, right? 2 into 1. 2 factorial is directly to, I'll just input 2 factorial here. Okay, so I get here minus 16 over 9. So it's minus 16 over 9. And this is what? X to the power, because x cube into power 2, the powers multiply, x to the power 6. So this is it. This is the expansion for 4 marks. Okay. So these are the first 3 non-zero terms. So then let's move on to part B. Use the expansion from part A with x equal 1 over 3 to find the rational approximation to cube root of 31. Okay, so they are asking you to use x as 1 over 3. By the way, do you know how they have got this particular, how do we say, the valid range? Do you remember how we take the valid range in a binomial expansion? So they are this particular, because you might be wondering how this came over here. But you need to remember in your, we have learned when you have a binomial expansion is 1 plus x to the power n, this expansion is only valid if the modulus of it is x value, whatever the x figure you have here, is less than 1. So in our question, we have 1 plus 4x cubed to the power 1 over 3. So in order for our expansion to be valid, the modulus of 4x cubed should be less than the 1. The modulus of this 4x cubed, this particular value should be less than 1. I mean, I'm just explaining you how this value came over here. The 4 can come out of the modulus sign. 4 is a constant, and then you have modulus x cubed less than 1. So x cubed is less than 1 over 4. Then we remove the cube, and it becomes the cube root. 1 over 4 cube root. And that's how you get here the cube of, basically 1 to the power of anything is 1. While 4 to the power of 1 over 3 is the cube root. Anyway, this is not asked. They're not asking us to find this, but this just tells us what are the x values we are supposed to use in this particular equation, because we can't put any value who is out of this range. You should understand modulus x means x is less than 1 over cube root 4 and it's greater than minus 1 over cube root 4. So basically you are only allowed to use x values who are inside this range into this particular equation. You can't use anything outside of it. Okay, so then they are asking us to use the expansion from part A with x equal 1 over 3. Okay, so then definitely x equal 1 over 3 should definitely fall inside this range. Otherwise, they would not ask you to put x as 1 over 3. Anyway, we don't need to check that because they have clearly told us to use x as 1 over 3. So let's use x as 1 over 3. This was something extra. It's not required for this question. Okay, it's not required for the question. I just wanted to remind you all what this rule is, how this came up, because otherwise you might be wondering what is this. Okay, it's not required here. All we need to do is the x values that we use to our expansion must fall within this range. Okay, so we will use x as 1 over 3, 1 over 4x cubed. So I have 1 over 4x cubed to the power 1 over 3. I'm supposed to replace my x with 1 over 3. 1 over 3 to the power 3. And then whole thing to the power 1 over 3. Do you realize what's happening here? I replace the x with 1 over 3. So replace all the x values with 1 over 3 now. So I end up getting here 1 plus 4 over 3 into x is 1 over 3 to the power 3 minus 16 over 9 into 1 over 3 to the power 6. Okay, so type this part in the cal. We'll type each part in the cal separately. So first of all, 1 plus 4 into 1 over 3 whole thing to the power 3. Who is this? This is 31 over 27. 1 plus wait. So yeah, so 1 into 4 times. I'm typing the left hand side, by the way. So I'm supposed to replace all my x values in the entire expansion with 1 over 3, and I'm supposed the question says to get a rational approximation to cube root 31. So basically I have to make cube root 31 the subject here. So I type the left hand side of my expression without giving the power 1 over 3 just to get the value inside here. So I get 31 over 27. So this side I get 31 over 27 whole thing to the power of 1 over 3 equals the other side. The other side, let's type it directly. So I get here 1 plus 4 over 3 into 1 over 3 to the power 3 minus 16 over 9 into 1 over 3 to the power 6. 6,869. 6,561. So I get this. Okay, now the thing is, I think you can see we already, I want to get rational. Rational means what? By the way, a rational approximation means can we get decimal answers? No, a rational approximation means it must be a fraction answer. It should not be decimals. Okay, so you must get a fraction answer. Do not convert decimals at any point. Okay, so then I think we can see I have the 31 here. Do you say I have 31? Okay, so the power 1 over 3. Let's separate it out. So So this is 31 to the power 1 over 3, which is the cube root 31 over the cube root of 27. So 27 to the power 1 over 3. I think that answer, it comes directly in the cal, right, as 3 cube root of 27, because basically 27 is 3 to the power 3. 3 to the power 3 and with the power 1 over 3, you could type it in your cal and you would directly get the answer of cube root 27 as 3. So basically this is cube root of 31 over 3. 6869 over 6561. Now take the 3 to the other side and multiply. 6869 over 6561. We multiply with the 3. So what do we get here? 6869 over 2187. So it's basically typing this in the cal. So this is the rational approximation for cube root 31. Okay, do you understand? Question number 3. The curve C has parametric equation x equals 3 plus 2 sine t, y equals 6 over 7 plus cos 2t, and the t values are given in the range between minus pi over 2 to plus pi over 2. Show that C has Cartesian equation. Okay, so you have to get this Cartesian equation. Okay, so how do we get about finding this Cartesian equation? What would be the strategy? Basically, Cartesian equation means what? You need to get rid of the t, right? Because these two are two parametric equations. X in terms of t, y in terms of t. X and y are separated with the t variable. So to get a Cartesian equation, you have to eliminate the t factor and get your x and y back together. So how do we eliminate the t here? So basically your t is in the form of a trigonometric. You have sine t and here you have cos 2t. So what do we do here? So actually for sine t and for cos 2t, I think you can see for cos 2t, do you remember we actually have the cos double angle rule in terms of sine. Cos 2t, what's the equation for cos 2t? The relevant equation 1 minus 2 sine squared, because there are three equations for cos 2t. The relevant one here is cos 2t equals 1 minus 2 sine squared t. Let's input that value here, y equal. You can see in your show that equation also y is already subjected, right? So then should we go to change the order of this particular equation with y subjected? No, leave it there. The best thing you can do here is we need to make sure y is subjected at all times. So what we'll do here is, I get here y equals 6 over 7 plus cos 2t. Who is cos 2t? 1 minus 2 sine square t. Are you with me? And then what do we do? The sine square t, basically the sine t value I can get from the first equation. Okay, so use the first equation. So I'm not going to change the order here and make sine the subject. No, because I already show that we can see y is the subject already. So leave it like this. So I'll take the other equation, x equals 3 plus 2 sine t. X minus 3 equals to 2 sine t. Sine t equals x minus 3 over 2. Is that okay? Shall we input that value? Seven plus 1 shall I input as 8? 7 plus 1 is 8. Minus 2 times, who is sine square? X minus 3 over 2. Not just that, square. So a whole bracket around this and a square. Be careful. Now it's a matter of simplification. Let's simplify. Y equals 6 over, be careful when you simplify, it's 6 marks for this question. 2 into, so it's x minus 3 square. So x minus 3 into another x minus 3. And don't forget that you have the square affecting the 2 as well. So 2 square will give you 4. Yeah, and then we can cancel in this case the 2 and 4. So I get here 2 times 1, 2 times 2. You know, one of the best way, now this looks really confusing for us to work with. So one of the best ways to express this particular fraction is by writing it in this manner. Look, I'm going to write this as y equals 6 divided by, or we can say 6 into also. If you all want, you could do it at 1, 6 into 1 over. Shall I write it directly like that? We could go 6 into 1 over because it would be a lot helpful. No, we'll write as division. 6 divided by, okay, 6 divided by 8 minus x minus 3 into x minus, basically x minus 3 square over 2. So I'm going to leave it first. I'm not going to make it to division to multiplication. First, I want to fix this particular fraction here. Let's fix it first. 6 divided by, what do I get here? So 8 over 1. When I take the common denominator, I get 8 times 2 is 16 minus, can you all expand the bracket here? The denominator is 2 now, and make sure you put a bracket because there is outside a negative sign which would affect all the multiples that come out of this particular multiplication. So be careful. So I get here x square minus 3x minus 3x is minus 6x minus 3 into minus 3 is plus 9. Are you with me? So then open the bracket now. Y equals 6 divided by 16 minus x square plus 6x minus 9. Whole thing divided by 2. Is that okay? 6. Then the next thing is the division you can turn to multiplication. You turn the thing upside down. 2 over 16 minus 9 is 16 minus 9 is 7. 7 plus 6x minus x square. This is okay. 7 plus 6x minus x square. Okay, so now we need to kind of like, I think we have to show that here already, right? Because so 6 times 2, I get the 12 here. 6 over 1. So this is directly multiplying, right? You don't take common denominator here. We directly multiply. 6 into 2 is 12 over 7 plus 6x minus x square. You can see that I already have my two factors, 7 minus x and 1 plus 6. Do you realize it? So don't go, if you to go type this in the calendar and get the factors, be careful. You have a negative x square here. Okay. So be careful when you go to get the factors from your cal because you have a negative x square. So basically, since it's a show that and you have already got this particular expression, we can go for the final answer directly, right? Okay, so then we can go for the two factors are 7 minus 6 and 1 plus 6. So you can see this, if you open the bracket, we end up getting this. Okay. So we are not done yet after getting to show that. Okay. So they said us to find the values of P and Q. P and Q are constants to be found. And who are P and Q? P and Q are the limits for your x, basically the domain. It's your domain, the domain and range. So here, how do we get the domain for our x values? So they've given you the t values here, right? Basically the t values are supposed to be from where to where? Your t values are, they are supposed to be in between minus pi over 2 and plus pi over 2. And then I need to get my x values. So my x values are going to be what? X is equal to 3 plus 2 sine t. Do you see? X is equal to 3 plus 2 sine t. And basically, I think you can see that we have the sine t graph. So basically, in the sine graph, sine graph oscillates between 1 and minus 1. So be a little bit careful when they give you this range, because the sine graph has two peaks, one at 1 and the other one at minus 1. The minimum at 1 and the maximum at the maximum at 1, the minimum at minus 1. So I think when you take sine minus pi over 2, I believe sine minus 90 is giving you the minimum, right? Yes, if you take the sine graph, sine minus 90 is equal to minus 1, while sine plus 90 gives you the plus 1, which means basically at these two corners I have the two peaks, and that should give me the two x values that I want here, because I want all the set of possible x values. Okay, so here, because the two t values are giving me the two peaks of the sine graph, I get every x value in between them. Okay, so then what are my x values? So when t is minus pi over 2, so when t is minus pi over 2, I get x equals 3 plus 2 sine minus pi over 2 gives me, sine minus pi over 2 is minus 1. So 3 plus 2 into minus 1, which is 3 minus 2. 3 minus 2 is 1. And when t is equal to plus pi over 2, x equals 3 plus 2 sine pi over 2. 3 plus 2 times sine pi over 2 is 1. So 3 plus 2 is 5. So then what are your P and Q values? So P is the lower value, right? P is 1 and Q is equal to 5. Okay, do you understand? Okay, then part B, hence find a Cartesian equation for C in the form y equal a over x plus b plus c over x plus d. So basically we already have the Cartesian equation, the same equation they want you to find in this manner. So looking from here to here, I think you need to realize what has happened. It's quite simple what has happened over here, right? You can see the denominator, I mean you have like two separate x plus b, x plus d. So basically it's what? The denominators are split means they have used partial fraction. So all you have to do is take the fraction that you found and get the partial fractions. Let's find the partial fractions. So y equals, so here you can see this is the normal, this is the proper fraction, right? Not improper, which means we can directly go for the partial fractions. So let me write it directly. 12 over 7 minus x 1 plus x is equal to a over 7 minus x plus b over 1 plus x. Is that okay? Let's get the AB values. 12 equal a times 1 plus x plus b times 7 minus x. Is okay? Then when x equals to minus 1, 12 equals a into 1 minus 1, that's a 0, right? So b into 7 minus minus 1, which gives me b equal 12 divided by 8, right? 3 over 2. So I get b equals 3 over 2. And let's input the a value when x is 7. You could compare coefficient. You could use even any other x value here. Since we found one person, the other x value could be found by inputting any x value. So 12 equals a times 1 plus 7. B times 7 minus 7 is actually a 0. So a equals 12 divided by 8, which gives me again 3 over 2. So then let's break it up. They want us to find the answer y equal a over x plus b and c over x plus b. So 12 over 7 minus x equals a is 3 over 2 divided by 7 minus x. B is again 3 over 2 divided by 1 plus 6, right? Okay. So I brought the question over here. Now in this question, they want us to get this show that the first thing for the show that is they have told you the ABCD values are constant. They have not told you they are integers. Okay, that's the first thing. So 3 over 2 is okay, it's a constant. However, do we have this in the given form? So they've said here x plus b and x plus d, right? So x plus b and x plus d, I've got here 7 minus 6. So that doesn't look like it's in the format. Shall we fix that? So this is 3 over 2 divided by, let me take a negative sign out and I get a minus 7 plus 6. Are you with me? Plus 3 over 2 times 1 plus 6. So this minus, you can, a plus over minus end of the day gives you a minus. Minus 3 over 2 times x minus 7. Do you agree with me writing x minus 7? It's the same as minus 7 plus x, right? X minus 7, and then this is plus 3 over 2 times 1 plus x. Okay, so this looks in the format that they want. So A, B, C, D are constants, not integers. Okay, so that's the important thing. So having this 3 over 2 here the 3 over 2 is a constant. So you don't need to be worried that they are not integers. Okay. Okay, question number 4. A regular icosahedron of side length x centimeter shown in figure 1 is expanding uniformly. The icosahedron consists of 20 congruent equilateral triangular faces of side length x centimeters. Show that the surface area A square centimeter of the icosahedron is given by this equation. So it's just 2 marks. So I mean, the first look of this diagram, it might confuse you. But end of the day, it's made up of what? It's just made up of 20 equilateral triangle, congruent, identical. Basically, 20 identical equilateral triangle. All you need to do is get the area of one equilateral triangle and multiply it with 20. That's all you need to do. So that's why it's just 2 marks. So you get one equilateral triangle here. The side length they told you is x, right? Yeah, side length is x. Each side is x centimeters, and in a equilateral triangle, each angle is gonna be 60 degrees because all the side lengths are equal. Each and every angle is 60 degrees. So now what do? We use the area of the triangle. So area of one triangle. What is the equation we use? Half into half AB sine C. So we use the equation half AB sine C. Who is A and B here? X and X. Half X into X into sine 60. So how much is it? Half X square sine 60 is? So basically I get root 3 over 4x square. So then what is the surface area? Surface area of icosahedron is multiply this with 20. So 5 root 3x square, which is exactly the, show that, because the 4 and 20 will cancel out. And we get 5 root 3x square. Is this clear? Then let's move to part B. Given that the volume V cubic centimeter of the icosahedron is given by V equal 5 over 12, 3 plus root 5 x cube, show that, okay, look at this, show that dV by dA. Show that dV by dA is this equation, okay. The first thing is this, the volume equation is given to us. Are we trying to prove this volume equation? No, read the question and see what you need to prove. This equation is given to you and you are allowed to use it. What do we need to show? We have to show this particular equation. For whom? You have to show the equation for dV by dA. You have to show the equation for dV by dA. The other thing is this. This equation is given for the volume in terms of x. So the thing is, I have volume in terms of x. So when I differentiate, if I take this equation and differentiate, I am going to get what? dV by dx. Okay, first what we'll do is, let's get dV by dx. So volume equals 5 over 12 times 3 plus root 5 into x cube. So first I get dV by dx. dV by dx. Now the thing is, when you differentiate with respect to x, do you see that 5 over 12 into 3 plus root 5? All of these are what? Constants. So do we need to bother about these when we are differentiating? No, just leave it aside. So 5 over 12 into 3 plus root 5, you leave it, you let it be there, and x cube differentiation gives you 3x square. So that's the only thing that you need to differentiate here. So we can simplify the 3 and 12, right? The 3 over here and the 12 would cancel out. You get 5 over 4, 3 plus root 5 x square. It's a 3 over 1. That's why the 3 and 12 cancel out. Okay. Okay, so that's dV by dx. Now I'm supposed to get the show that for dV by dA. Okay, how do I get this A variable involved here? So first thing is, what we do is we take this A equation, because I need the A involved with V. So to do that, what we do here is, now don't go to substitution. Some of you might think, can't we input the x value here as substitute? That is also one option, but the powers are going to be a little bit of a problem here. So one of the easiest way to do this is, you can get dA by dx. Basically, your area equation is 5 root 3x square, which you found. So get dA by dx. Who is dA by dx? Differentiate with respect to x. 5 root 3 x square differentiation is 2x. So I end up getting here dA by dx equals 10 root 3x. 10 root 3x. Then the task that, so this is dV by dx, the other one dA by dx I found, but the thing is, I want to find dv by dA. Yeah, so we'll use chain rule here. dv by dA. How do we break it? dv by dx into dx over dA. This is basically the chain rule where I break this up. So dv by dx is 5 over 4 into 3 plus root 5 times x square into dx by dA is 10 root 3x. Do you agree with me? So we need to now simplify this and we should get our show that. Let's try to get the show that. I think we can see the show that already has a 3 plus root 5. So I don't want to touch this 3 plus root 5 with anything else. Leave the 3 plus root 5 because we need it to be clearly to be seen. Okay, so then I have here 5 into 10 into root 3. 5 into 10 root 3. I'll bring it front. 5 into 10 root 3. 3 plus root 5 x square and x gives me x cube.
Teacher, shouldn't it be 1 over 10 to root 3?
Yes, yes. dx over dA. Yes, 1 over 10 root 3. Yes. Yes. So let's change this. Okay. dx over dA should be the reciprocal. Yeah, this is dA by dx. So 1 over 10 root 3x. Yeah. Yeah. Then we get to show that directly. Yes. So then I can cancel out x over here, right? 1x would cancel out. And 5 and 4 also cancels out. 5 times 1, 5 times 2. Yeah, and then we get to show that quite nicely. 3 plus root 5 x remains on top. At the bottom you have 4 times 2. Yeah, the 4 multiplies with this 2 to give you 8. And there is a root 3 at the bottom. So this is our dv by dA, which is exactly the show that we wanted to find. Okay, do you understand? Then let's move on to part C. The surface area of the icosahedron is increasing at a constant rate of 0.025 square centimeters per second. So when they tell you the surface area is increasing at a constant rate of 0.025 square centimeter per second, what is the measurement they are giving you here? Square centimeter per second means this is dA over dt because it's the rate of change of area with respect to time. So dA over dt is 0.025 square centimeter per second is given to you. Find the rate of change of the volume of the icosahedron when x equals 2. Giving your answer 2SF. Okay, rate of change of volume means what do we need to find? Find the rate of change of volume means they are asking you to find dV over dt. We need to find dV over dt. So how do we find dV over dt once again? So again we need to break it up, right? dV over dt, how do we find? dV over, the thing is they've given us dA. So we'll use dV over, we'll break it with the letter A into dA over dt because basically the A to A cancels and I get dV by dt again. Do you see? Okay, so then dA by dt is given to us, but dV by dA needs to be found. Actually, dV by dA we have already found it in the previous part. So I can substitute that value. dV by dA is 3 plus root 5 over 8 root 3 x into dA by dt is 0.025, isn't it? And they've told us to use what? X equals to 2. So we are supposed to use x equals 2. Replace x with 2 and your final answer should be given to two significant figures. 3 plus root 5 over 8 root 3 into x is 2, 0.025. So give your answer to two significant figures. 0.019 cubic centimeters per second, right? Because it's rate of change of volume with respect to time. Yeah, so they've asked to give you answer 2SF and this is the answer to 2SF. Okay, is this clear? I hope it's clear with everyone. Okay, question number 5. Figure 2 shows a sketch of the curve with parametric equations x equal root 9 minus 40 and y equal t cube over root 9 plus 40. P values are given in the range between 0 and 9/4. The curve touches the x-axis when t is 0. Here at this point the curve touches the x-axis and meets the y-axis when t is 9/4. Okay, so then basically at t0 you touch the x-axis, at t9/4 you touch the y-axis. Okay. The region R shown shaded in figure 2 is bounded by the curve, the x-axis and the y-axis. So this is the region R. Show that the area of R is given by this particular equation where K is a constant to be found. Okay, so when we try to find these equations for area, now basically what's the basic, we have two equations that we learned for area. So the first equation we learn is area equal the Cartesian one, right? Integration of y dx, that's Cartesian. For parametric area, we use what? Area equals integration y dx by dt with respect to t. Are you with me? We use area y dx by dt with respect to t. Okay, and then we need to put the limits here, the ta and tb. Okay, now the first thing is I have my y value, but I need to get dx by dt. Okay, so this is the formula we need to use to get this show that. So I need to find my dx by dt. So let's get our dx by dt. X is equal to 9 minus 40, the whole thing root. So root means a power of half. So then when I use dx by dt, what do we get here? The power comes in front, right? Half. 9 minus 40 to the power half minus 1 is minus half. So first we take care of our powers, then we go inside and we differentiate inside. What do we get for the inside differentiation? 9 is 0, minus 40 differentiation is minus 4. Okay, so I end up getting here dx by dt equals minus 2 times 9 minus 40 to the power minus half. Is that okay? Okay, so this is what I get for my dx by dt. This is okay. Then let's get the area. Now how do we get the area? Area equals integration of y dx by dt. Now basically y dx by dt, wait, from with respect to t. Okay, let me input now the y and dx by dt values are found, and here I need to give my t limits. So how would you give your t limits here? Do we give it from 0 to 9/4 or from 9/4 to 0? Yeah. So the important thing is, because your x value starts now, your limits are supposed to go from x0 to whatever the x value is. So at x0, your t value is 9/4 at x0. And at the final x value, because we start at this point, this is the starting, this is the ending. This is the start to this is the end. The starting t value is 9/4, the ending t value is 0. Okay, because the starting x value is over here, that's why. And the ending x value is over here. So we need to put the corresponding t values in that order. Okay. So the starting t value limit is 9/4, ending t value limit is 0. Is this okay? So then let's input our values now. So y will be t cube over root 9 plus 40, right? And then multiply by dx by dt is minus 2 times 9 minus 40 to the power minus half with respect to t. dt, right here, over here, with respect to t. This is okay. So now I need to rearrange this equation and get what? I need to get this, show that. So let's just rearrange the equation here. So I end up getting here, first of all, minus 2 t cube, and you know what I'll do here? This is a negative half, right? Shall I bring it down? So this is root 9 plus 40. This is power minus half comes down as a power plus half. So basically power plus half means, in other words, this is square root. Because the square root means a power of half. The square root means a power of half. So the power negative half, I bring it down. I bring it down to the denominator. I bring it down over here and it becomes a power plus half, which is the root. And now I have root 9 minus 9 plus 40 with root 9 minus 40. Both of them are inside the square root. Since both of them have equal powers, since both of them are roots, I can multiply. I can take them, I can multiply them inside the root. Basically, if you have root a multiplied by root b, you can write as root a times b, right? You can do like this, root a into root b, separate roots. When you multiply, it's root inside a single root, you can write a into b. So I can use that rule over here. Integration minus 2t cube. Inside a single root, we multiply 9 plus 40 with 9 minus 40. The whole thing is with respect to t. So inside the root, what do we have now? 9 minus 40 into 9 plus 40. This is actually difference of two squares, right? A plus b, a minus b gives you a square minus b square, isn't it? So then I get here 9 square is 81 minus what b square here? 40 square is 16t square, a square minus b square. 9 square minus 40 square. 40 whole things, 16t square. So actually, I think we all get our show that almost, but there is the limits that we put are from 9 over 4 to 0, right? Then do you remember now the show that has the limits from where to where? 0 or 9 over 4, basically the other side. Do you remember the rules, rule of changing the limits in the integral sign? So if you have a to b and if you want to change the integral sign from b to a, what do you need to do here? If you change it from b to a, you have to take, it generates a minus sign. Okay, so basically you can see we already have a negative sign here. So if I take that negative sign into account, using this negative sign, I can change the integral sign. 9 over 4 to 0 can be written as what? 0 to 9 over 4. Yeah, if you want, you can take minus mark out here and then minus 2. Yeah. So let's put minus and then minus 2t cube. You can do it like this. There are many ways of doing. So I just change the sign and I put a negative sign now. Or you could say you use up this negative sign and change these two. So anything is fine. And then the 2, of course, the 2 is a constant. I can bring it out. The minus 2 with the minus makes it a plus 2. And the integral sign from 0 to 9 over 4. Then you have t cube over root 81 minus 16t square with respect to t. And that's how show that. So this is our show that, and my k value becomes 2. Is this clear? Okay, part B, using the substitution u equal 81 minus 16t square, or otherwise find the exact area of R. So obviously when they give us a substitution, this should be the easiest method that we can go ahead. So I will definitely go with the substitution here. So the substitution is u is 81 minus 16t square. I'm going to apply that substitution to this sum and we are going to find what the exact area of R. So let's get it done. U equals 81, this is part B, right? U equals 81 minus 16t square. So when they give you a substitution, what's the first thing that you are supposed to do? Differentiate the given substitution, because we will need to replace the dt. Basically, this entire sum, everyone in terms of t, must be converted to u, including the dt. So the reason to substitute this, the reason to differentiate the given substitution is to create a substitution for the dt. So when I differentiate u with respect to t, shall I differentiate? I'll write here du by dt, which means I'm differentiating with respect to t. Equals 81 differentiation is 0 minus 16 times t square differentiation is 2 t to the power 1. So this gives me du by dt equals minus 32t. Okay, and then I want to make dt the subject. So du over minus 32t equals dt. This is clear to you. Dt goes to the other side as a multiplication, minus 32t comes to the other side as a division. Okay? Okay, then let's substitute. And before substituting, since we are going to convert the entire sum into u, we need to change the t limits into u limits. So let's change the limits as well. So our t limits are from 0 to 9/4. Can you all convert it to the respective u limit? Convert this to the respective u limit. So 81 minus 16 into 0 square. So what does it give me for u? So when t is 0, 81 minus 16 times 0 gives me 81. Do you see this? I didn't even write it because it's clearly seen here, right? And the other one 9/4. Can you all type it in the cal? 81 minus 16 into 9/4 square. T is 9/4. Yeah, how much? 9/4 square. Basically, yeah, 4 square, 16 cancels, 9 square, 81. 81 minus 81 is 0. So I have given the t limits in order from the lower limit to the upper limit here. Okay, so then the 81 is the lower limit and 0 is the upper limit. Do you see? The 0 was the upper limit. Sorry, for t, 0 was the lower limit. Okay, and 9/4 is the upper limit. Okay, so that same model needs to go for u as well. Okay, then let's convert our sum. Okay, let's substitute now. So when I substitute, I get here. So my sum is 2 times t cubed over root 81 minus 16 t square dt. Okay, I'm about to substitute to this sum now. Okay, so then basically the 2 stays here. The integration limits from 0 to 9/4 becomes 0 becomes 81, 9/4 becomes 0. And then before I go to replace everyone just like that, let me first write the, I'm first going to replace my dt. And after I get rid of the, after I look into dt, then later I will convert the other guys inside. So dt is going to be, let's substitute this dt value here. du over minus 32t. So this is an into. Okay. Right. So then let's, I think we can see a t will cancel out here. And I get here t square. Is that okay? And the minus 32 minus 1/32 can come out. Yeah. Yeah. The limits also, if we want, we can change 0 to 81. Let's go for that for the next step. So I have here t square over root 81 minus 16 t square. So now, if you are doing the substitution properly, the entire sum in terms of t must be entirely converted to u. There should be not even a trace of t here. So how do I remove t entirely? We have here u equals 81 minus 16 t square. So u equals 81 minus 16 t square. I think denominator we can directly get rid of it, right? The denominator is directly 81 minus 16 t square is u. So this is root u. T square on the numerator, of course, we need to fix it a little bit. So it's going to be 16 t square equals 81 minus u. T square equals 81 minus u. So it's going to be 81 minus u over 16 du. Is this okay? Then let's simplify this a little bit. Minus 2 over 32 is minus 1 over 16. And then 81 minus u over, I hope you can see that this 16 and root u, you can bring the 16 down to the denominator. Okay, yeah, and you can take the 16 out as well. Okay, so then I'll bring the 16 down. Okay, and then I have root u here with du. Okay, this 16, I brought it down to the denominator. Basically, both of them are denominators. 16 we could take out, and also if you want, we could exchange the limits, because that would create another negative sign and get rid of the negative sign outside. Do you agree with me? Minus 1 over 16 times another 1 over 16 comes out, because I'm taking this 1 over 16 out. And then another minus sign will come out, because I'm changing the limits from 0 to 81. It's not actually compulsory to change the limits. You could leave the limits exactly as they are. That is totally fine. Okay, leaving the limits as they are it's just okay. There's no problem in it. Okay, so I'm just changing this so that things become simplification wise, maybe it becomes easier for us. So minus minus is a plus, 1 over 256. 16 times 16 is 1 over 256. And then this is 0 to 81, the limits. And then I get here, now to integrate this, once again, to integrate, we can't keep them together, we need to separate them. So I get 81 over root u, that is basically u to the power half, minus u over root u, du. Okay, so then I get here 1 over 256. 81 over root u is 81 u to the power minus half minus u divided by root u gives me what? U divided by u to the power half is u to the power 1 divided by u to the power half, power subtract, and you get u to the power plus half. So I think now we are ready to integrate, right? So let's integrate 1 over 256. 1 over 206. Let's input now. 81 u to the power minus half plus 1 is plus half, divide by half, right? Minus u to the power half plus 1 is 3 over 2, divide by 3 over 2. We are integrating, isn't it? And our integration limits are from 0 to 81. So 1 over 256 times 81 divided by half gives me 81 divided by half is 162 u to the power half minus 2 over 3 u to the power 3 over 2 from 0 to 81. So I just fix this and then we'll input our limits because it's easy. So I'm writing extra steps. You could of course skip a few of these steps to make it things easier for you. 162 into u is 81 to the power half, 2 over 3 into 81 to the power 3 over 2. So this is the first limit, minus you must input the second limit. So my second limit will be, when I input 0, I think you can see the whole thing becomes 0. So can you all type, they want the exact answer here, right? They want the exact answer here. So 162 into root 81 to the power half is basically root 81. That gives me 1458 minus 2 over 3 into 81 to the power 3 over 2 is 486. So the other part minus 0 is not necessary. So type the whole thing in the cal and get the exact answer. So we get 243 over 64. So we get 243 over 64. So this is what? This is the exact area. So what we do is this part answer we got was for the area to show that. So then when we use the substitution, because we couldn't integrate directly, and we got the answer for the area of the shaded part. Okay. Question number 6. 3 consecutive terms in a sequence of real numbers are given by k, 1 plus 2k, and the third term is 3 plus 3k, where k is a constant. Use proof by contradiction to show that the sequence is not a geometric sequence. Okay, so in proof by contradiction, once again, I'm repeating you the steps that you need to know for to do a proof by contradiction. Step 1 is you assume that the given statement is false. And in step 2, you use logical steps to show that the statement that the assumption you made will lead to something impossible. And the third statement is you say it's a contradiction and therefore the original statement is true. That's how we do a proof by contradiction. So now here, what's the assumption we made? Now they say here 3 consecutive terms in a sequence of real numbers are given by this. We have used proof by contradiction to show that this sequence is not a geometric sequence. So it's not a geometric sequence. So what is the assumption you use? You say that you have to say about that what they're saying is false. So what is it? Assume the sequence is what? We assume that our sequence is geometric. So we take the negative of the statement they give us. Okay. So we assume the sequence is geometric. So now let's work as if this is a geometric series, and we'll use logical steps to show that that our assumption will actually be wrong. We need to prove that this assumption that we took here, the negative of the statement, the assumption is false. Okay. So in a geometric sequence, they've given you 3 consecutive terms. So what can we do from 3 consecutive terms if it's a geometric sequence? We can take the common ratio. Geometric sequence has a common ratio. So then we can divide and get the common ratio, and since we assume it's geometric, the common ratios between each and every pair of terms must be equal if it's geometric, right? So then what's the common ratio? The front term, you take the 1 plus 2k, you should divide by the previous term. 1 plus 2k, you divide by k, because these are consecutive terms. This r that you took from these first 2 terms must be the same that you get from the next 2, which is what? 3 plus 3k divided by 1 plus 2k, because when you divide the when you divide by the term behind the previous term, you must get the common ratio. So basically, since we assume it's geometric, the common ratios we get from both pairs must be the same. Okay, so now let's simplify and get an equation for k, and let's see how we try to show this statement is wrong. So 1 plus 2k will multiply with 1 plus 2k. Is that okay? And the other one, k multiplies with 3 plus 3k. So 1 plus 2k into 1 plus 2k is 1 plus 2k plus 2k plus 2k into 2k is 4k square. So here we get k into 3 is 3k plus k into 3k is 3k square. Is that okay? So take everything to one side. So here I get 4k square and plus 3k square to this side is negative 3k square. 4k square minus 3k square is k square. Here 4k, 2k, 4k, subtract 3k, I get plus k. And I get plus 1 equals to 0. So basically this equation tells me that this the values of k, in this sequence will make this particular equation 0. Okay. So now what would be the next step? Now I need to show that somehow this is wrong. We need to show that this leads to something impossible, or basically something impossible in the sense maybe you could try to show that one. Now they are saying this equation leads to something that makes this equation 0. Basically there are solutions. So then if you try to solve this equation, you might realize when you try to type in the ABC values, you'll realize that you'll end up getting complex answers, right? No solution. So however, so one thing you could do is you could use, we could do completing squares, or you could get the, so then we could use completing squares, or as you all were suggesting me, we could use the discriminant and show that this leads to complex roots, right? Okay, so both of those methods are fine, but you just need to make your conclusion solidly. Okay, you need to make a proper conclusion. I'll use completing squares here. Discriminant is also fine. Okay, so k plus completing square gives me this is 1k, so half square, so minus, and square of 1 over 4, 1 over 2 is 1 over 4 plus 1. So I'm just considering. Okay, I'm just considering the k square plus k plus 1. Let me write this properly. Now I want to show that there are no k values who will make this equation equal to 0. Isn't it? So that means basically there are no solutions. So if I take k square plus k plus 1, this can be written as the completing square is k plus half square minus 1 over 4, and there is a plus 1. So this gives me k plus half square minus 1 over 4 plus 1 is 3 over 4. I think you can see in this particular equation, k plus half square is always a positive term, right? When you have a square term, it's always positive. So basically, you can write k plus half square is greater than or equal 0 for all k. Do you agree with what I'm saying? Because for each and every k value, when there's a square, it always gives you a positive term. The lowest you could get is 0. You get lowest 0 when k is minus half. here. But otherwise, for every other k value, because it's a square function, you end up getting a positive answer. So to this positive answer, k plus half square, what do? They add a, so to that answer, k plus half square, when you add a 3 over 4, what happens? This is definitely becoming what? Greater than, not even greater than or equal 0 now. The answer actually will, okay, so if you add 3 over 4 to both sides, you can say it becomes greater than or equal 3 over 4. But basically, I want to show it's greater than what? It will be greater than 0. You could say it's greater than or equal 3 over 4. But end of the day, I want to show that this is not going to be equal to 0. Okay, it's going to be greater than 0 for all k values. It's greater than 0 for all k values, for all real k values. So what does this mean? Are there solutions for this equation? Can I get answers that work out for this particular equation? Do we have solutions that work out for this particular equation? No. So what does it mean? This is a contradiction. So write down, this is a contradiction. This is a contradiction, and what does it mean? Therefore, the original statement. What's the original statement? Therefore, the sequence is not geometric. Okay, so this is it. This is the proof by contradiction. Okay, so there is a request to do the question also by using the discriminant. Okay, so then when we come to this point, so you come to this point, k square plus k plus 1 equals 0. So basically we need to show that there are no solutions to this equation, because if there are solutions to this equation, it means you have k values who work in this geometric sequence, right? So then what we could do here is we could use the discriminant b square minus 4ac. Get the b square minus 4ac value. B is 1, right? Here a is 1, b is 1, c is 1. All three are 1. So 1 square minus 4 into 1 into 1. What do we get here? 1 minus 4, I get minus 3. So discriminant is less than 0. So discriminant is less than 0 means what? There are no real values. No real values for k. There are no real values for k that satisfy this equation. So if there are no real values of k that satisfy the equation, what does it mean? This means this is it's a contradiction, because it says that our assumption is wrong. We assume that this is correct. We assume that this equation is geometric. Thereby, we assume that this equation would have solutions. So then we come to a point where there are no solutions, which means it's a contradiction. The statements do not agree with each other. And you can write, therefore sequence is not geometric. Okay, so both these methods are perfectly fine. Okay. Question number 7. Figure 3 shows the design of a doorknob. The shape of the doorknob is formed by rotating the curve shown in figure 4 through 360 degrees about the x-axis where the units are in centimeters. The equation of the curve is given by this. Okay, 1 over 4 minus x into e to the power x, and x values are between 0 and 4. Show that the volume V cubic centimeter of the doorknob is given by this particular equation, which has 3 marks, where k is a constant to be found. Okay, so I think you can see how the doorknob has been formed, right? The curve is given, you rotate it 360 degrees and you create this 3D shape. Okay, so how do we get the volume? What's the volume equation? This is, by the way, this is now not parametric. You can see it's a Cartesian equation. Y and x are together. So what's the volume equation? Volume is equal to integration pi y square dx. Is that correct? The volume equation pi y square dx. And then the integration, we put the limits. So our x limits are from where to where? Your starting x value is at 0. Remember, dx means we put the x limits. So starting x value is 0, ending x value is at 4. Okay, so pi is a constant, take it out. Take pi out. 0 to 4. Okay, y square. So who is y? Y is 1 over 4. 4 minus x, ex. Whole thing square, dx. So this is 0 to 4. 1 over 4, so the power 2 goes to each and every element here, right? 1 over 4 when you square, it's 1 over 16. Okay, so I'll take the 1 over 16 now. Is that okay? And it gives me pi over 16. I'll take this 4 out. The next one is 4 minus x. It becomes 4 minus x square. Ex also be squared, and then the power x and the the powers multiply, and you get e2x with respect to x. Okay, so then we need to open the bracket, and then we'll leave the e2x out. We need to just open the 4 minus x, right? And then we immediately get the show that, right? So I get here pi over 16. Integral limits are from 0 to 4. So 4 minus x square. Immediately if you open 4 minus x into 4 minus x. So that's 16 minus 8x plus x square. That okay? I just open the bracket directly. 4 minus x into 4 minus x. And then outside you have a e to the power 2x. So did I get the show that? Yeah, it's the same thing in a rearranged form. Let's rearrange. Pi over 16 from 0 to 4. I get x square minus 8x with respect to x. So this is my show that, and the constant k is given as what? I to the power 2x. Yeah, yes, we have I to the power 2x. Yeah, and the k value here is what? According to what we have found, the k value is pi over 16. Is that clear? Then they tell you part B. Hence, find the exact value of the volume of the donut. Give your answer in the form. Okay, so we have to give our answer in this form where P, Q, R are simplified rational numbers. Okay, so here P, Q, R are all rational numbers, meaning they are all fractions. Okay, so how do we integrate this? How do we get started with the integration here? Okay, let's think about this for a moment. How do we start integration here? Okay, so how do we integrate this? You can see you have a e to the power 2x and you have here x square minus 8x plus 16. Of course, if you open the bracket, you get x square e2x and you get a x e2x. So you should remember in your P4 book, you've done x ex like x square ex. These kinds of integration were done in a certain section in the integration book, and that was integration by parts. So to do integration by parts, I mean, if you open the brackets and do the integration by parts, you'll notice that you will have to go integration by parts for each and every section, which is quite hectic. So we don't want to go there. We will use integration by parts, taking the entire x square minus 8x plus 16 as a u value, and e to the power 2x can be a v dash. So integration by parts rule, if I remind you, integration by parts. How does it work? Integration of uv dash with respect to x is uv minus integration vu dash. So this is the rule where u becomes u dash by differentiation and v dash becomes v through integration. Okay, u becomes u dash through differentiation, v dash becomes v through integration. Okay, so then basically I have here my thing I need to integrate here. So shall we take this part? I'll take the part that I need to take, that I need to integrate x square. So I'm keeping the pi over 16 outside for the moment. Or shall we take it and do the sum? We'll take it and do the sum, otherwise we might forget. So I'm getting the volume here, right? They're asking me to find the volume in this particular format. Okay. So volume equals pi over 16 integration 0 to 4. X square minus 8x plus 16 e to the power 2x. So in this equation, I will be using this person as my u and e to the power 2x is my v dash. So when I write it down here, u is x square minus 8x plus 16, which gives me u dash is the differentiation. 2x minus 8. Okay, so I'll write my u and u dash separately, so I can easily input to this equation. When I write it down separately, I can easily input into the equation. So v dash is given as e to the power 2x. V dash to v is integration. Okay, v dash to v is integration. So e to the power 2x, when you integrate, it's e to the power 2x divide by 2. Do you agree? 2. So let's input the value here. Volume equals to pi over 16. Okay. So how do we integrate? So I'm going to use the rule here. So I'll use a big curly bracket over here. uv minus integration v u dash. So I have written the uv, all the values that we want are written at this point. So let's input the values. u is x square minus 8x plus 16. U into v is e to the power 2x over 2. uv minus integration v is e to the power 2x over 2 into u dash is 2x minus 8 with respect to x, and then close the curly bracket. And then I'll open the bracket with pi over 16. So I end up getting here volume equals pi over 16 times e to the power 2x over 2 times x square minus 8x plus 16. So I arrange this. Here I get again minus pi over 16, and the 1 over 2 comes out front here. So I get here inside the integral sign e to the power 2x minus 8 with respect to x. Okay, so now you can see we have our integral limits here given from 0 to 4. So normally now you can see here now the integration is not over yet actually. But you can see here we again have ex and a x product, which means we have used integration by parts here again. So I think you can see here that we have already one part that is out of the integral sign. So I think the best option here to save you time would be to input the limits for the parts that are done with the integrals, the parts that are done with the integration. This part is done with the integration. So let's input the limits and finish it off. It would be definitely save you some valuable time. Okay, 0 to 4. So let's get it done. Volume equals, this is pi over 32. Okay, 16 times 2 is 32. Then I get here, let's input the values now. E to the power 2x into 4 is e to the power 8 times. Can you all input 4 here? 4 square minus 8 into 4 plus 16. How much? 0. 4 square minus 8 into 4 plus 16 is a 0. Okay, that's 0. Then minus, next one is we need to replace the e to the power 2x. I've taken the pi over 32 out here actually. I hope you can see pi over 32 is taken out. I'm inputting the limits to these guys. Okay, so I'm using here e to the power 0. What do we get here? 0 minus 0 plus 16. Okay, and then outside this I have pi over 32 integration of e to the power 2x times 2x minus 8. Okay, I hope this part was clear to you. I took the pi over 32 out and replaced all the x values with 4 first, and then minus I replaced all the x values with 0 afterwards. So I end up getting here now e to the power, 8 into 0 is 0 basically. This whole thing is a 0. Here I get e to the power 0 is 1. So I get minus 16, right? Pi over 32 into minus 16. And that's all we get from that bracket. Okay, so then here minus pi over 32 times integration of e to the power 2x with 2x minus 8 with respect to x. Okay. So again, we need to use parts by integration here. So this is my v dash and this is my u. So v dash is, we'll start with u. U is 2x minus 8. U dash is equal to 2. Differentiation of 2x is 2. V dash is e to the power 2x. So v is e to the power 2x divided by 2. Agreed? So it's again parts by integration. Can you all simplify minus 16 over 32 here? Minus half, right? Minus half pi. Is that okay? So I get here minus pi over 32. Let's use the uv minus vu dash rule again, integration by parts. So uv, who is u? U is 2x minus 8. uv is e to the power 2x over 2 minus integration v is e to the power 2x over 2 into u dash is 2 with respect to x, and you close the integral sign again. Yes, so we get here minus pi over 2. Here we get minus pi over 32. Now this part we are done with the limit. So now again this part is out of the integral sign, right? So shall I input it with the minus pi over 32? Minus pi over 32 with this gives me minus pi over 32 times e to the power 2x over 2 into 2x minus 8. So this guy, which just came out of the integral sign, which means we need to apply the limits here. Okay, and the other one, be careful here, minus pi over 32 with this gives me minus is a plus pi over 32. The 2 and 2 cancels and you get integration of e to the power 2x with respect to x. So here also let me use the limits. Wait, let me multiply 32 and 2 here. 32 into 2, let me take it as 64. Is that okay? So this is 64. And now this is the part that just came out of the integral sign. So we'll use our limits here from where to where? 0 to 4. Okay, this part is not yet integrated. So we have another one part to integrate. So I get here volume equal minus pi over 2 minus pi over 64 times. What do we get here? E to the power 2x, we replace the x with 4. So e to the power 8. 4 times 2 is 8 minus 8 is 0, right? 0 minus e to the power 0. 2 times 0 is 0 minus 8. And then we are done with that part. I'll move to the next part. Shall we finish that part as well? Here we don't need to use any integration by parts. We can directly integrate e to the power 2x as what? E to the power 2x over 2. And then here also we can use our limits from where to where? 0 to 4. So I end up getting here volume equal minus pi over 2. So this is the whole thing is a 0. Here I get e to the power 0 is 1. Minus is plus, right? Minus pi over 64 into plus 8. Is that okay? Plus pi over 32 into what do we get here? E to the power 8. Shall I take the 2 out? We'll take this 2 out of the sign. So I get pi over 64. And I get here e to the power, then replacing x with 4, e to the power 8 minus e to the power 0. Okay, so then we get here volume equal minus pi over 2 minus pi over 64 into 8 is pi over 8, right? Plus pi over 64 into e to the power 8. Here e to the power 0 is actually 1. So we end up getting minus pi over 64. Is that okay? Can you all simplify this? So I think we can take all these terms. Minus pi over 2, minus pi over 8, minus pi over 64. How much is it? I'll just type half. We can give the pi on our own. Minus 1 over 8, minus 1 over 64. Gives me minus 41 over 64. Minus 41 over 64 pi, and then plus pi over 64 e to the power 8. Then we'll take pi over 64 out, and I end up getting minus 41 plus e to the power 8. Or in other words, pi over 64 into e to the power 8 minus 41 coming in cubic centimeters. Okay, so this is the volume equation. Are you all okay with this? Okay. Okay, moving on to question number 8. With respect to a fixed origin over the points A and B have position vectors. Okay, 6, 6, 2, 6, 0, 7. So basically they have given you two position vectors A, B on your line. So one is point A The other is point B, 662, 607. So these are the position vectors, are the coordinates of two particular points on your line. So they say the line L1 passes through points A and B. So this is my line L1. Write down an equation for line L1. Give your answer in the form R equal P plus lambda Q, where lambda is a scalar parameter. So basically, equation of a vector line is in the format what R equal A plus, we use R equal A plus lambda B. So what does each person stand for? So A plus lambda B in here, P plus lambda Q. So P should stand for the position vector, while Q should stand for the direction vector. How do we get the direction vector in a case like this? So the direction vector, when they give you two coordinates on the line, how do we get the direction vector? So direction vector, now they have given you the OA, OB with respect to the origin. They have given you two coordinates on the line. How do we get the direction vector? We get the direction vector by using the AB vector. So AB vector is equal to B minus A. You remember B minus A, or it's AO plus OB. Basically, it's B minus A. So minus 662 and B 607. So 607 minus 662. So what does it give me? Minus 6 plus 6 is 0. Minus 6 plus 0 is minus 6. Minus 2 plus 7 is 5. Okay. So this gives me the AB vector. Now that is my direction vector. So R equal P plus lambda Q, or R equal A plus lambda B. So here definitely the first person represents a coordinate, a position vector on your line, while the other one is a direction vector on your line. So R equals, the P is, you could use what? You could use either A or you could use either B. For this P, for the coordinate, for the position vector on the line, you could use any one of these two and it's perfectly okay. I'll use the first guy, 662. Lambda times Q is the direction vector. The direction vector is what we found as AB. Okay, so this is the format, the answer for part A. So R equal P plus lambda Q, this is the equation. R equals 662 plus lambda times 0 minus 6, 5. Okay. Let's move on to part B. The line 2 has equation R equals 314 plus mu times 159. Where mu is a scalar parameter. Show that line 1 and line 2 do not meet. Okay, how do we show that two lines do not meet? So then we found the line 1. Yeah, how do we show that they don't meet? We basically show that when we solve the two equations, that the lambda and mu values don't agree for all the three coordinates. Okay, it doesn't agree for all the three coordinates, because if it's meeting, the lambda mu, the single lambda mu value you find should agree for all the three coordinates. Okay, for example, now in line 1 here, what's our coordinate? R equals, can you all simplify this and write down? 6 plus 0 lambda. 6 plus 0 lambda, basically 6. Then the other one, 6 minus 6 lambda. Next one, 2 plus 5 lambda. And then line 2. So if I go on with line 2, I get here R equals 3 plus mu into 1. That is 3 plus mu. 1 plus 5 mu. The next one. Okay. Yeah, and then what we do is we equate the first two lines. Equal, because if the lines are meeting, the first two lines, the x coordinates should be equal. 6 plus 0 lambda is basically 6 plus 0, just 6. Equals 3 plus mu, and I get my mu value is equal to 3. Then go for the second equation. This is from the x coordinates. When you equate y, we get 6 minus 6 lambda equal 1 plus 5 mu. So we have found mu value as 3. So 15 plus 1 is 16. 6 minus 6 lambda is 16. 6 minus 16 is 6 lambda. Is that correct? Minus 10 equals to 6 lambda. And then what do we get here? Lambda is minus 5 over 3. We get lambda is minus 5 over 3 from next equation. Then how do we show that they meet? It meets if the third coordinate, if the lambda and mu is agreeing to the third coordinate as well. Okay. So shall we check on the third coordinate? So when we check the third coordinate, 2 plus 5 lambda. I think we'll try to get it separately. We are trying to show that it doesn't meet, right? So 2 plus 5 lambda and 4 plus 9 mu. If they are meeting, 2 plus 5 lambda should be equal to 4 plus 9 mu. So what is 2 plus 5 lambda? 5 lambda is minus 5 over 3. How much is it? Minus? Yeah, minus 19 over 3. Then how much is, so 2 plus 5 lambda must be equal to 4 plus 9 mu. So is it happening? 4 plus 9 mu is this, right? 31. So do you see that these two values do not agree? So that means from the third coordinate, the 2 plus 5 lambda is not equal to 4 plus 9 mu. I equated the first two lines, the xy coordinates, and I got the lambda mu, basically getting two simultaneous equations. I substitute those lambda and mu values into my third equation, and what happens? It's not equal. If it's equal, then the lines will meet. But if they are not equal, the lines do not meet. So here, therefore, the lines do not meet. Therefore, lines do not meet. Is this clear? Shall we move on to the next part? Part C. The point C is on line 2 where mu equal minus 1. Okay, basically what you do is you go here, replace mu with minus 1 and you get the coordinate of C. They say find the acute angle between AC and line 2. We give you answer, giving you answer to decrease to 1 dp. Okay, so that we can easily do. How do we do it? First, let's get the C coordinate. OC. How do we get the C coordinate? Go to the line 2 equation and replace what? Replace the mu with minus 1. Go to this equation, replace the mu with minus 1. So what do we get here? For the C coordinate, 3 plus minus 1 into 1 is minus 1. 3 minus 1 is 2. 1 minus 5 is minus 4. 4 minus 9 is minus 5. Is this okay? 2 minus 4 minus 5 is a C coordinate. Okay, so then they say now we have the lines L1, L2 do not meet, right? So I have my line 1, line 2, they don't meet. The point C is on line 2, right? Find the acute angle between AC and L2. Okay, A and C. Okay, so basically A is on line 1, right? AB was on line 1. Line 1 and line 2 don't meet, but basically we are talking about 3D lines here. So even if I draw it with a different direction, you need to realize that they pass, one line can go above, the other can go underneath, right? So then your other point, the point C is on line 2. And they want the acute angle between AC and line 2. The acute angle. So how do we get the acute angle between AC and line 2? So what's the equation we use to get the angle between two vectors? We use the equation, the dot product, the scalar product. Cos theta equals A dot B over modulus A into modulus B. This is the equation we learned to get the direction, the angle between two vectors. So who are two vectors here to this angle? Okay, so you could just get the, we can use one vector as the direction of direction vector of AC, and the other one is what? The direction of line 2. You could use the line 2. One direction vector is the AC direction vector. The other one is the line 2. Okay, so these are the two vectors that are surrounding this. Are you with me? The same angle, this one. So these two. The AC direction vector and the line 2 direction vector. And I can get the angle between AC and the line 2. Okay, so we'll get this angle. Okay, so did I find the AC direction vector by the way? No, right? Let's get the AC direction vector. So AC is equal to C minus A, or basically AO plus OC. So I think we found the A coordinate. What was our A coordinate? A coordinate was 662, right? C coordinate is 2 minus 4 minus 5. So minus 6 plus 2 is minus 4, minus 6 minus 4 is minus 10, minus 2 minus 5 is minus 7. This is my AC vector. Okay, so this actually you could even find CA vector if you want. There is no problem in it. Okay, because we need to get the two direction vector, the dot product of the two direction vectors. So for the direction vector, you could use AC or you could even use CA. It actually depends on your diagram. So I have taken it this way. So you could use AC or CA. Both of them are perfectly fine. Okay. So then we get here. Then we get here the A dot B. Shall we find the A dot B? So basically here your A represents, here my A represents the AC direction vector. And my B represents what? The direction of what? Line 2. Are you with me? So if there's anyone here who wants to use CA as your direction vector, you are perfectly allowed to do it. There's no problem. Okay, so then shall we get the A dot B? A dot B is the AC direction vector. Dot product with the line 2. What was the line 2 direction vector? Line 2 direction vector, the one with the mu. It is the direction vector 1, 5, 9. That's the direction vector, the one with the parameter. Get the scalar product. Minus 4 into 1 is minus 4. Minus 10 into 5 is minus 50. Minus 7 into 9 is minus 63. How much do we get? Minus 100. Minus 117. Minus 117. Shall we find the modulus A, modulus B as well? Modulus A is the modulus of the vector AC. So what's the modulus of the vector AC? You square all the components and you root it. You square each and every component here and you root it. What do we get here? Root 165. Get me modulus of the vector B also. Vector B is the direction of line 2. So what was the direction of line 2? 159. 1 square, 5 square, 9 square, root. How much is it? Root 107. Okay, so I have everything I want here. So let's input now. Cos theta equals A dot B is minus 117 over modulus A is root 165 into modulus B is root 107. Now here there's one thing you need to realize. Okay, so now people who use CA as the direction vector, if you use CA as your direction vector, you would get your A dot B as plus 117. Okay, the people who use AC gets negative 117. So end of the day, if you use cos inverse of negative, you will end up getting the obtuse angle. Do they want acute angle? Have the role acute angle? Yes. So if you use cos inverse of the negative, you will get the acute angle. So if you get the you will get the obtuse angle. So if you subtract that with 180, you can get the acute angle. Or else you can directly use cos inverse of the positive of this. Okay, so if you use cos inverse of the modulus of this value, you will end up getting the acute answer. Do you understand? Once again, if you use cos inverse of this negative figure, you will end up getting an obtuse answer. Okay, and that answer, if you subtract with 180, you can get the acute answer. If you want to directly get the acute answer, just take the positive figure of this and take cos inverse. You can directly get your answer. So anyway, both are fine. I want the positive answer. So what is the theta? I'll use the arc cos 100 and the positive figure. If I use the positive figure, I'll get the acute. Otherwise, I'll get the obtuse. Even if you get the obtuse, it's fine. If you subtract from 180, how much is it? In degrees to how many decimals? 1 dp. 28.3 degrees. So this is the acute angle between AC and the line 2. Okay. Okay, question number 9. Find the derivative with respect to y, which means you need to differentiate with respect to y. Everywhere you differentiate with respect to a y term, if you differentiate, it becomes 1. Okay. So I think you can see in this question we only have y terms. So when you integrate, so you can, if you want, take any letter here and say maybe you could put, it's up to you all. You could use this as x. So anyway, you don't need to use any letter if you all are confident, or else you can say this is x equals to this. Okay, or else we don't need to use any letter at all. So anyway, how do we integrate 1 over? Sorry, not integrate. We need to find the derivative. Derivative means we need to differentiate 2ln y to the power 2. So yeah, to differentiate, the best thing is we'll take this, we'll make the derivative, we'll make sure it's in the numerator. So I get 1 plus 2 ln y to the power minus 2. Okay, so then let's differentiate with respect to y. So I will differentiate with respect to y. So regardless with whatever you are differentiating, what's the rule? The priority must always first go to the power. So I will write like this, d by dy. I'm going to take d by dy of 1 plus 2 ln y to the power minus 2. This means we are supposed to differentiate this person with respect to y. Okay, regardless of what you are differentiating, first priority goes to the power. Bring the minus 2 in front and you have 1 plus 2 ln y to the power minus 2 minus 1 is minus 3. After you are done with the power, go inside. Differentiation of 1 is 0. Then 2 times ln. And whenever you have ln x, it's 1 over x. So ln y should be 1 over y. We are doing with respect to y. So into 1. Okay. And differentiating y. So basically ln x is 1 over x. That's with respect to x. Ln y with respect to y is 1 over y. Okay. So then when we simplify this, I get here 2 minus 2 into 2 is minus 4. Shall I bring this minus 3 down? The y is down. 1 plus 2 ln y to the power 3. Okay, so that's it. So this is the answer for 2 marks for part A. Okay. Part B, hence find a general solution to the differential equation 3 cosec 2x dy by dx equals y plus y into 1 plus 2 ln y to the power 3. So how do we find a general solution to this equation? Basically, this is the first order differential equation. How do we find the general solution? Basically, we need to separate the y and x, isn't it? So separate the variables 3 cosec 2x dy by dx equals y times 1 plus 2 ln y to the power 3. When I separate variables, I'll take the dx terms to the other side. So this is 3. If you can do these things at once, you can do 3 cosec 2x dy y times 1 plus 2 ln y to the power 3 dx. So have we separated the variables successfully? No, because this side dy, I'm having x terms. Here with dx, I'm having y terms. I need to take the y terms to the side with dy. X terms to the side with dx. So what do I get here? I get here 1 over y times 1 plus 2 ln y to the power 3 dy and 1 over, I can leave the 3 up, right? Shall I leave the 3 up? I'll just take the cosec 2x only down. Cosec 2x with respect to x. So that means this 3 stays up here. The 3 stays up here. Is this okay? And then to get the general solution, we need to integrate. We need to integrate this side with respect to y. We need to integrate this side with respect to x. And that's how we get the general solution. Okay. Right, then let's think how can we integrate this. Okay, so now how do we integrate when we come to this point? Okay, so this is the tough challenge here to figuring out how we actually need to integrate this. So you need to be a little bit tactful here. The rule we use here is the rule f dash x fx to the power n in P3. So if you have f dash x fx to the power n, the integration is fx to the power n plus 1 divided by n plus 1. So this is the rule. So the first thing what I do here is I have 1 plus 2 ln y to the power 3. There's this power here. I'll take it up first. Let me take it up. I'll leave the, let's take the 3 outside. 3 is a constant. I can take it out of the integration. 1 over y is here. And then I'll take 1 plus 2 ln y. I'll take it up. It becomes power minus 3. sorry, power 3 becomes power minus 3 dy. So I have still not integrated. I've just taken this guy up. The 1 over the y, 1 over y stays down. Here cosec 2x is actually sine 2x with respect to x. Okay, now what do we see here? So 1 plus 2ln y. Okay, 1 plus 2ln y to the power minus 3. So what happens here? This is my fx. 1 plus 2ln y is my fx. Or we can say it's our fy in this case because it's with respect to y, it's our fy. So what's the f dash? Do we have the perfect f dash y outside? 1 differentiation is 0. 2 times ln y differentiation with respect to y is 2 into 1 over y. So 2 over y. Basically the f dash y here is 2 over y. So you can see I already have 1 over y. The only thing that I'm missing here is the 2, the top 2, the constant 2. So I could input the 2 here, and to cancel that I can put a half out. Okay, we can input constants as we wish. Okay, but not variables. So I input a 2 here and half out. This creates the perfect f dash y. So f y to the power and n, and here f dash y. Basically this rule. Okay, so I have this perfectly. So that gives me the opportunity to use this rule. So we add 1 to the power of this fx guy. So that means I get here 1 plus 2ln y to the power minus 3 plus 1 is minus 2 divided by minus 2. Do you agree? The other side, of course, sine 2x integration is something that you are familiar. Sine integration is minus half cos 2x. And then plus c. So what's the format they want us? No, they have not, they've asked us to find the particular solution. Find the general solution. Yeah, so you could just simplify this a little bit more and leave it. Minus 3 over 4, 1 plus 2ln y to the power minus 2 equals minus half cos 2x plus c. So you could leave it because they've not told you to make y the subject. You could leave it like this. It's up to you all. Okay, you could leave it at this point. Shall we move to the last part? Show that the particular solution means a very, one particular answer, right? Show that the particular solution of this differential equation for which y equal 1 and x equal pi over 6 is given by this answer. So they've told you to use what? Y equal 1 when x is pi over 6. Shall we use it? Y equals 1 when x is how much? Pi over 6. So when y equal 1 and x is pi over 6, shall we input the values? And we need to get the, we need to make what the subject? We need to make y the subject. Y equal e to the power a sec x minus half. So we need to get that kind of a show there. So let's input our answer. I get here minus 3 over 4. 1 plus 2 ln y is 1 to the power minus 2. Are you with me? Minus half cos 2 times x is pi over 6 plus c. Basically, when we get the particular solution, I had to first find the unknown c term first. So what do I get here? ln 1. Who is ln 1? That's 0. ln 1 is 0. 1 plus 0 is 1. So basically, this is minus 3 over 4 because 1 to the power minus 2 is just 1. Here I get minus half cos pi over 3. How much is cos pi over 3? Half. So minus 3 over 4 minus 1 over 4 plus c. How much do we get for c here? C is minus half. So let's input the value now. Substitute the value. Minus 3 over 4. 1 plus 2 ln y to the power minus 2 equal minus half cos 2x. C is minus half. So I think everyone has a negative sign here, right? All the terms. So we can get rid of it. And let's bring the power minus 2 down. So it's a power 2. I could take 2 is a common denominator here. Cos 2x plus 1. I remove the negative sign from everyone, okay? So the whole, the entire term becomes positive. Okay, I need to make y the subject, isn't it? We need to make y the subject. It was sec x, right? Not sec 2x. It's sec x. Okay, then let's simplify 3 times 2. Shall I bring the cos 2x plus 1 down here? And I'll take the 4, 1 plus 2 ln y to the power 2 to the other side. Are you okay with what I did here? I took the 2 up here. And I took the 4 into 1 plus 2 ln y square to the other side. And I took this cos 2x to this side, denominator. Is that okay? Shall I bring the 4 also here? Because my ultimate target is to make y the subject, right? And I think you saw in the show that we had a sec x. Sec x means 1 over cos x. So do we have cos 2x? No, right? So we need to fix that as well. 3 times 2 is 6. Here 4 times 1 plus cos 2x here. Equals 1 plus 2 ln y to the power 2. So before I go any further for cos 2x, because I know I need to create a cos x, I need to create a sec x here. There's no 2x, there's no cos 2x, there's no sec 2x in the show then. So what we do for cos 2x, we have 3 equations for cos 2x. I need to use the one that can get rid of this 1. Cos 2x is 1 minus 2 sine square x. The other one is 2 cos square x minus 1. I think if we use that over here, we can get rid of this 1. So let's use that for cos 2x. 6 over 4 times 1 plus cos 2x is 2 cos square x minus 1. 6 and 4, yeah, we can simplify. That gives me 3 over 2, right? Here the 1 and 1 would cancel. And then this inside this, I get 2 cos square x. Is that okay? 1 plus 2 ln y square. So basically I end up getting here 3 over 4 cos square x. 1 plus 2 ln y to the power 2. First thing is we'll remove the power 2 to the other side. The power 2 removes as the square root, right? So square root of 3 over 4 cos square x is equal to 1 plus 2 ln y. So we are close to making y the subject now. Square root of 3 will stay as it is. 4 becomes a 2. Cos square x becomes cos x. 1 plus 2 ln y. Are you okay with it? Then I think we wanted to create a sec x, right? So you can see we'll get 3 root 3. I'll bring the cos x up as sec x root 3 over 2. Is that okay? The plus 1 comes as minus 1 equals 2 ln y. Is this okay? And then root 3 sec x minus 2 over 2 equals 2 ln y. So the 2 comes down. I took the common denominator. Now the 2 comes down here. Root 3 sec x minus 2 divided by this 2 along with this 2 gives me a 4 equals to ln y. Final push. What is it? Making y the subject. So how do we make y the subject? E to the power. Okay, before that, I think I'll separate this in the show that we had things separated out, right? I think there was a half. We had a half, right? A sec x minus half. This is now the final part here. So log to index form. How do we convert log to index form? So ln means log base e, isn't it? So turning log to index, we get here what? E to the power root 3 over 4 sec x minus half equals to y. Is this to show that? This was, we had y equal a sec x minus half, isn't it? So a is root 3 over 4. Okay. So I hope all of you understood the, so we got this, right? I hope all of you understood this. And this is the end of the discussion of the January 2022 P4 paper.